circle. Let's find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. So you might want to start by picturing what these things are. Y equals x minus 1, it's a line. This one's a parabola, but the square is on y, so it's going to be a sideways parabola, one that opens up either left or right. Okay. All right, let's start by finding, I need to know where these things intersect. So let's start by finding the intersection points. Okay. Okay, so let's do that. We've got a little bit of a problem here. Look at our equations. They don't say y equals in both of them, right? So it's not just setting them equal to each other. How am I going to find the intersection?
Can you square both sides of the first equation?
You could, And then it would say y squared equals that. And that's the same thing as in the first equation, it's already solved for y. So I can just plug that into the second equation. But that's the exact same thing you just told. So you're going to take your first equation, y equals x minus 1, and I'm going to plug this into the second equation. So you plug in into second equation. And you're going to get, it'll be x minus 1 squared equals 2x plus 6. When you plug in, you should only have one variable. You shouldn't have y's and x's. We only have x's. That's good. And I want to solve for x. How am I gonna, what would you do to solve for x, your first step? Would what? Foil, right? On the left I have squared, so that means I gotta foil. So let's do that. You're gonna FOIL this out, x squared minus 2x plus 1. That's a lot, doesn't look as nice, but it is nicer. I can then subtract everything to one side. So let's move everything to the side with x squared on it. X squared minus 4x minus 5. Okay. What did I do previously? I factored this. Can someone tell me what that factors into? -5 and what? And plus 1. Okay. So it looks like my two solutions are x equals 5 and x equals -1. So those are the two places, those are my two x values where they intersect. But I'd actually like to know the points themselves because I need the graph. So having the x coordinates is not enough. I need to get the y coordinate. So you take these, plug them into either one of the functions that we had at the beginning because they intersect there, so they have to have the same value. So you get to pick. I had the equation x minus 1, that was y. And I had y squared equals, so I have two possibilities. I have y equals x minus 1, and y squared equals, it was 2x plus 6. So you can plug these into either one. I think the first one's easier, hopefully you do too. Plug it in. So if I plug in 5, you'll get 4 for y, so it looks like my first intersection point is 5, 4. And if I plug in -1 in place of x, I get -2. So my second intersection point is -1, -2. Okay? These are my two intersection points. Once we know where they intersect, we can draw our region. So let's do that. Let's draw our region here. So I need a little bit of room, I think. Yeah, that should be enough. Oh, I'm not marking with a pen yet. Okay, so I'm going to start by plotting these 2 points that I have. So I have -1, -2, and 5, 4. 5, 4. Okay. I'm going to want to move this part up a little bit there. Okay. So the first equation, y equals x minus 1, that's just a line. I have 2 points on the line, so I just need to connect them to get my first graph. Just connect these two here through a line. If I can draw a straight line here. Okay. Okay. So the other equation, I said it's the sideways facing parabola. Maybe we need one more. We have these 2 points. We need one more. So what I want to do is if I plug in, hold on. If I set y equal to 0, so I wonder, yeah. So I take this equation here, and I need another point, and so I'm going to see what I get when I plug in y equals 0 here. So if I plug in 0 for y, I'm going to get 2x plus 6, and x is going to be -3. So I got this point -3, 0. Okay. So this parabola, it's going to open up. I have 3 points here. This one, and this one. So it's going to open up. The mouth is going to point to the right side. Okay. So it looks like my graph is going to look like this and this and that. Okay. I've got my picture of my region, and now I want to see what happens. I need to know top minus bottom, right? But look here. If I'm to the right, the top is the parabola, the bottom is the line. But if I move over to the left, the top is the parabola and the bottom is the parabola. So it kind of changes, which means I would need two separate integrals to compute this, which you could do. It would be a little bit messy. So instead, what we're gonna do is we're gonna integrate with respect to y now. So when you were integrating with respect to x, you had a top and a bottom, but with respect to y, you're gonna have a right and a left function, okay? So you're gonna take your equations and you're gonna solve for x in them. Okay. Solve for x in your equations. So in the first one, if I solve for x, I get x equals y plus 1. And in the second one, if I solve for x, you're gonna get x equals 1/2 y squared minus 6, or 1/2 y squared minus 3. So there's my first one and there's my second one. Okay. All I did is I took my equations that I started with and I solved for x in them. So I said now we have a right and a left. Let's look back at our picture and figure out which one's on the right. So imagine you have a horizontal line here. The one on the right is the line. Okay? The one on the left is the parabola. Okay? So this one is, I'm going to call this XR, which means right. And then this one is going to be XL. It's the one that's on the left. Okay? And so your integral works very similar. It's going to be A equals. And now you're going to have these numbers in terms of y. It's going to be XR minus XL. Just like top minus bottom, now it's right minus left. Okay, so I said my top one, or my right one is y plus 1. Minus my left one, 1/2 y squared minus 3. Okay, and then all you need to do is figure out what numbers go here on your integral. But to do that, just look at your picture and look at your range of your y values. Okay, so let's go to the picture real quick. What's my smallest y value I have? -2. What's my largest y value? 4? I mean, it's 4. That was my y value. So these bounds here are going to go from -2 to 4. Okay. And we're running short on time, so I'm just going to tell you if you integrate this, you're going to get 18 for the area. Okay. You could do this again in terms of x if you want, but you're going to have two integrals, and they're going to be messy because they're going to have square roots in them. So it's really best to just integrate in terms of y for this kind of stuff.